Good morning, sir. Today, we will present our topic entitled Broadband Seismometer BBVS-120. This presentation is compiled by Indra Dewantara, Lamtorang Erlanto Simbolon, Dayyan Febryan, Brema Sihombing, and Zahra Aulia from the Instrumentation Major Batch 2024 STMKG. This presentation is part of our academic study under the supervision of Mr. Benyamin Haryanto Rusanto. In this presentation, we will discuss the basic concept, working principle, and application of the BBVS-120 Broadband Seismometer in seismic monitoring. Let us begin with the introduction of this instrument. As mentioned earlier, the BBVS-120 is a broadband, three-component seismometer designed for high-precision seismic monitoring. This instrument measures ground motion simultaneously along three orthogonal axes: the vertical axis Z, the north-south axis N, and the east-west axis E. By recording motion in all three directions, the seismometer provides a complete representation of seismic wave propagation, which is essential for accurate analysis of earthquake source and wave characteristics. The BBVS-120 is capable of detecting wide range of seismic signal, from local microearthquake to distant teleseismic events, making it suitable for both regional and global seismic observations. In the next sessions, we will discuss its core components and working principle in more detail.
Advantages that make it a superior choice for seismic monitoring. First, it features a very wide frequency response, recording vibration from a 0.033 Hz or a 30-second period up to 50 Hz. This allows a single instrument to capture everything from low-frequency distant earthquakes, known as teleseism, to high-frequency local vibration and cultural noise. Second, it boasts a huge dynamic range of over 140 decibels. This ensures that the sensor is highly sensitive for detecting subtle microearthquakes, yet robust enough to record strong earthquake waves without experiencing signal saturation or clipping. Furthermore, its compact all-in-one design integrates the sensor, electronics, and automatic leveling system into a single, environmentally resisting casing. Lastly, the system provides high stability and accuracy with very low internal noise even when facing temperature change. Now, let's examine the work principle of the BBVS-120, which operates on the force balance feedback principle. When ground motion occurs, the internal inertial mass moves relative to the frame. A highly sensitive capacitive sensor immediately detects even the slightest displacement of this mass. Instead of letting the mass swing freely, an electronic circuit instantly generates a counteracting electromagnetic force to push the mass back and keep it centered. The output signal we record is actually the precision voltage required to maintain the equilibrium. This closed-loop mechanism is what allows the instrument to achieve such high linearity and a wide frequency range. Looking at the technical specifications, the BBVS-120 is designed for a high-performance operational range. Its operating band covers very long periods of 120 seconds, which is approximately 0.008 Hz up to 50 Hz. This enables the recording of both very slow tectonic waves and higher frequency local waves. In terms of environmental durability, This seismometer can operate effectively in extreme temperatures ranging from -20 degrees Celsius to +50 degrees Celsius. It can also withstand high humidity conditions provided there is no condensation. With a dynamic range of over 140 decibel and low self-noise, these specifications make the BBVS-120 a versatile and reliable tool for long-term seismic monitoring.
Operational range. The operating range of the BBVS 120 generally covers a very wide frequency band from long periods of 120 seconds up to about 50 Hz, enabling it to record seismic signals from very slow waves to higher frequency local waves. This instrument typically operates with a large dynamic range and low self-noise, making it effective for recording both very small and moderate vibrations. In terms of environmental conditions, 122nd class seismometers can generally operate at temperatures of approximately -20 degrees Celsius to +50 degrees Celsius and under high humidity, provided that condensation doesn't occur. With these capabilities, the BBVS 120 can be used in a wide variety of field conditions for long-term seismic monitoring as well as geophysical research.
In this part, we will explain the main internal components of a broadband seismometer and their function. At the core of the instrument, there is an inertial mass combined with a three-axis pendulum system, vertical, north, south, and east-west. These elements act as the primary sensitive components that respond directly to ground motion during seismic event. The ground motion detected by the pendulum system is then converted into electrical signal by a motion sensor, such as a geophone or velocity sensor. This conversion allows the very small vibration of the earth to be measured accurately in an electronic form. To ensure that the measurement remains stable and do not oscillate excessively, the system is equipped with a damping mechanism and precision springs. These components control the movement of the inertial mass, reduce unwanted resonance, and improve the overall stability of the signal. The weak electrical signal produced by the sensor are processed by a preamplifier and signal conditioning circuit. This tech amplifies the signal and removes noise, resulting in a clean and reliable output that can be further analyzed. In addition, feedback electronics are used to maintain a flat and stable frequency response over a wide range of seismic frequencies. This feedback system ensures that the instrument responds consistently to both low frequency and high frequency ground motion. Finally, the seismometer includes a level control module and internal calibration system. These components allow precise adjustment of sensitivity and accuracy, ensuring that the instrument remains properly aligned to produce trustworthy measurement over long periods of operation.
Installation. The installation of the BBVS 120 seismometer is carried out at a stable site, ideally on bedrock or hard ground, to minimize environmental noise disturbances. The sensor is installed inside a vault or enclosed chamber to maintain temperature stability and protect it from mechanical interference. The installation process includes leveling the sensor so that it is perfectly horizontal, setting the axis orientation according to true north, and releasing the mass lock after the sensor has been properly installed. The final stage of installation involves initial calibration to ensure that the instrument's sensitivity and response meet the specified requirements.
On this slide, I will explain how the BBVS-120 seismic station handles and delivers its data. First, the data transmission uses the SeedLink protocol. This protocol allows real-time data streaming from the MKLX digitizer to a central server, such as BMKG. The data format used is miniSEED, which is the international standard for seismic waveform data. Another important aspect is low latency. For earthquake early warning system like Inateus, data must arrive within seconds after ground motion is detected. The BBVS-120 system is designed to meet this requirement. The data also includes metadata, such as station location, elevation, sensor orientation, and instrument response. The output data from BBVS-120 supports several important applications. First is microtremor, which is often used for subsurface structure studies, including the HVSR. Second, for local and regional earthquakes, the data helps in rapid detection, determining the epicenter location, estimating magnitude, and supporting early warning systems. The station also records teleseismic earthquakes, which are earthquakes occurring thousands of kilometers away. Finally, the data contributes to scientific research such as seismic tomography, crust and mantle studies, and monitoring volcanic activity. The BBVS-120 measures ground velocity in three components, which is vertical, north-south, and east-west. This three-component recording allows us to capture the complete three-dimensional motion of the ground, which is essential for analyzing seismic waves and earthquake behavior. Ground vibrations are first converted into analog electrical signals by the sensor. The signals are then digitized into digital data for storage and transmission. The system uses 24-bit resolutions for high detail and typically records at 100 to 200 samples per second, which is suitable for most earthquake monitoring needs. The BBVS-120 has a wide frequency range, so it can record both low and high frequency seismic waves. It also has a large dynamic range, allowing it to capture very weak ambient vibrations as well as strong earthquake motions without distortion.
miniSEED and SEED-Link. Output data from the BBVS-120 seismometer is stored and transmitted using the internationally standardized miniSEED format, specifically designed for efficient and structured storage of seismic data. This format contains seismic waveform data along with precise timing information, simplifying the process of storing, exchanging, and analyzing data between systems. For real-time data transmission, the BBVS-120 is integrated with a monitoring network via the SeedLink protocol, which enables continuous streaming of seismic data from the station to a central server with low latency. The combination of miniSEED and SeedLink ensures fast, reliable data reception and compatibility with a wide range of software. And the last is conclusion. The BBVS-120 is an impressively versatile tool that acts as a bridge between the physical ground and digital safety system. By integrating a three-component sensor with force balance feedback technology, it achieves a massive dynamic range of over 114 dB, allowing it to capture everything from sublocal microearthquakes to massive teleseismic events without distortion. I see its real value in its all-in-one rugged design and its ability to stream data instantly via the SeedLink protocol, ensuring that high-precision seismic signals are delivered with low latency for critical early warning system.